In this video, we will solve a few dosage calculation problems for injectable medications. Let's take a look at the first one. Order 50 mg of medication Z intramuscularly 3 times a day. Available vial that reads 40 mg is per 1 milliliter. How many milliliters will the nurse administer? And we will be rounding to the nearest tenth. First of all, let's write down what do we know. And we know that 40 mg is 1 ml. This is my is line. And now what do we need to find? We need to find 50 mg. $50 mg is X ml. We are going to set our milligram under milligram, milliliters under milliliters. We're using here DKP method, and it's essential to set it up just like that. The same measure goes under the same measure. If you're working with hours, they go under hours. If you're working with ounces, ounces go under ounces. Now we're going to find a diagonal with two numbers in it. This diagonal has only one number and X. We cannot work with this diagonal. We're going to choose this one. It has two numbers we can work with. 50 and 1. We're going to multiply these two numbers and we're going to divide by the third number. X equals 50 times 1 divided by 40, and that equals 1.25 milliliters. I know I found milliliters because I set my X under milliliters. Now the problem is telling us to round to the nearest tenth. So I'm going to look at my hundredths place and I'm going to see if it's 5 or more. Then I'm going to increase my tenths by 1. If it's less than 5 here, I'm going to leave it just like that. So in this case, 5 is going to increase my tenths place. And that will become 1.3 milliliters. Here's our next problem. The order is for potassium chloride 20 milliequivalents to be added to IV solution. How many milliliters will the nurse draw up? And a label is given. 40 milliequivalents of potassium chloride, and the concentration is 2 milliequivalents per milliliter. It's important to understand what numbers you have on your label. This 40 milliequivalents, this represents a total amount in this package. So this one doesn't help us to solve our problem. What we need is the concentration, 2 milliequivalent per milliliter. Always on your labels, look for concentration of the medication. It could be so many milligrams per so many milliliters. It could be so many units per so many milliliters. But to solve your problems, to go from whatever units problem has to your milliliters to draw up in the syringe, you need to find that concentration. So many of these units or milliequivalents or milligrams per so many milliliters. Always find your concentration. So here, 2 milliequivalent per milliliter. We're going to start working with that. 2 milliequivalent is 1 milliliter. I need to give 20 milliequivalent. 20 milliequivalent is X milliliters. And once again, using DKP method, we're checking, do we have milliequivalents under milliequivalents? Do we have milliliters under milliliters? After checking that, we're finding out diagonal to multiply, and we're dividing by the third number. X equals, in this case, 20 times 1 divided by 2. And that equals to 10 milliliters. I found my milliliters because I set my X with milliliters, so I know this is my answer. Here's our next problem. The order is to administer 10 milligram of medication ZIM once. Available strength is 4,000 microgram per milliliter. So how many milliliters will the nurse administer? Right away, you can see that order is in milligrams and availability is in micrograms per milliliter. So why don't we go ahead and just convert those micrograms to milligrams to make our life easier. And some of you may do it in your head if you're good at it and you had a lot of practice, but some of you don't know how to do it in your head. We're gonna set it up as DKP method. We're gonna say 4,000 microgram to milligram. I don't know how many milligrams that is. That's X milligrams. But I know conversion of micrograms to milligrams, and I know that 1,000 micrograms is 1 milligram. Multiply on diagonal, divide by the third number. And we get 4. So 4 milligram is what we have available per milliliter, right? 4 milligram per milliliter. 4 milligram is 1 milliliter. I have to give 10 milligram. How many milliliters is that? 4 milligram, 1 milliliter, 10 milligram is X milliliters. Again, I multiply on diagonal, divide by the third number. 10 times 1 divided by 4. 2.5 milliliters. This is how much I will administer if I order to give 10 milligrams. Every time you set up your method, your DKP method, check yourselves. Do I have my micrograms under micrograms, milligrams under milligrams, milliliters under milliliters? It's very important. Here's our next problem. Order 80 units per kilogram of medication Z stat subcutaneously. Patient weighs 188 pounds. Medication Z available for sub-Q use, 10,000 units per milliliter. How many milliliters does the nurse administer? And we'll be rounding to the hundreds. First, let's look at our order, and we see that it's per kilogram of body weight, and our patient weighs way more than 1 kilogram. So let's figure out how many kilograms our patient weighs and how many units are appropriate for our patient. So we're converting pounds to kilograms first. 188 pounds. I don't know how many kilograms that is, but I know that 2.2 pounds, that's 1 kilogram. So 188 pounds is X kilogram, 2.2 pounds is 1 kilogram. Using my DKP method, I set up pounds under pounds, kilograms under kilograms. I'm going to multiply on diagonal, divide by the third number. 188 times 1 divided by 2.2. Or if you remember by now that this is how we find our weight from pounds to kilograms, by just dividing our pounds to dividing by 2.2, and that's how we find our weight, and it is 85.45 repeated kilograms. Now, once you found this number on your calculator, do not lose this number. Don't try to round it. Preliminary calculations are not rounded. We only round to the hundredths at the very end. So keep that number on your calculator or write it down, but definitely do not round it. Next, now we found our weight. Let's figure out how many units are appropriate for this patient. If 80 units is for 1 kilogram, 80 units is for 1 kilogram of body weight. how many units is for my 85.45 repeated kilogram. And once again, I'm checking, do I have my units under units? Do I have my kilogram under kilogram? And then I'm going to multiply on diagonal and divide by the third number. 80 times 85.45 divided by 1. And that equals, and I'm going to keep this a weight, what I found. I'm keeping it on my calculator, and I'm just going to time it by 80. And I get new crazy number here, big number. 6,836.36 repeated. And I found units, right? My X was under units, so that is how many units I will administer to this patient who weighs that much. Okay, so far so good. Now we need to figure out how many mLs are we going to administer. If the concentration given is 10,000 units per ml. As always, for DKP method, I'm writing 10,000 units is 1 ml. I need to give this number of units. I'm going to put my units under units. And I'm going to say 6,836.36 repeated is X milliliters. And now again, multiply on diagonal, divide by the third number. $6,000 and change times 1 divided by 10,000. Now here, be careful, don't lose those zeros, okay? It's very easy when you have hundreds of thousands or tens of thousands of units, or sometimes you'll have millions of units, like with penicillin, sometimes can be million. Don't lose your zeros, okay? Count your zeros carefully. Did I use all my zeros? So we're dividing by 10,000, and see, I kept that number, this number right here, I kept on my calculator, and all I need to do now is to divide by 10,000. And I get 0.683636 repeatedly. The problem tells me to round to the nearest hundredths. So I'm looking at a thousandths place. And if that number is 5 or more, I'm going to increase my hundredths place by 1. But if this number is less than 5, I'm going to leave it just like that. And I got 0.68, and that was my milliliters I was looking for. And that is my answer. So let's review what we did. We first converted our weight to kilograms. We kept that number on a calculator. We did not round here. Then we multiplied our weight by our units per kilogram to find how many units is it that we give to this patient who weighs more than 1 kilogram. We kept that number on a calculator. We did not round here either. And then we plugged it into our concentration of 10,000 units per milliliter, and we found that we'll give 0.68 milliliters after rounding to the nearest hundredths. Here's our next problem. It's a little more complicated. We need to administer medication Z, 8 microgram per kilogram per day, IM, divided equally every 12 hours for a child who weighs 33 pounds. Available medication Z, 0.05 milligram per milliliter. So how many milliliters do we need to administer to this patient in one dose? Let's take a look. How can we clarify things? First of all, let's start with weight. Weight is given in pounds. The order is per kilogram of body weight. Let's go ahead and convert our weight to kilograms. If you remember that it's just a matter of dividing by 2.2, go ahead and do that. If you don't remember, if you doubt yourself, go ahead and set it up as a DKP method. 33 pounds, I don't know how many kilograms that is. But I remember that 2.2 pounds is 1 kilogram. I check if I have my pounds on the pounds, kilograms on the kilograms, and then I'm going to multiply the two numbers on diagonal and divide by the third number. And I find that 33 times 1 divided by 2.2 gives me 15 kilograms. My child weighs 15 kilograms. Now let's figure out how much of the medication is appropriate for this child. So 8 microgram is for 1 kilogram of body weight. Then how much do I have to give to this patient? 8 microgram is for 1 kilogram. 8 microgram is 1 kilogram. My patient has 15 kilogram. How many microgram is that? 8 microgram is 1 kilogram. X microgram is 15 kilogram. Multiply on diagonal, divide by the third number. And I got that 120 microgram is appropriate to give to my patient per day. We're still per day here, okay? Now, let's figure out what's the rest of the order saying. So this amount I'm going to give per day intramuscularly, divided equally every 12 hours. So this is my daily amount, and I need to split it into doses to figure out what's one dose. So if it's every 12 hours, that means I have to divide it by 2. There are 24 hours in a day. I have to give it every 12 hours. That means twice. 120 divided by 2 will give me 60. However, if you can think that way, because sometimes it's not that easy, right? Every 12 hours, it could be every 4 hours, or every 6 hours, and every 8 hours. If you get confused like that, go ahead and set it up as a DKP method. And you say that 120 microgram is per day, right? Which is 24 hours. I need to find what is it per 12 hours. $120 is 24, is over 24 hours. What about for 12 hours? How many microgram is that? Multiply and divide. And I found 60 microgram. This is how many microgram I will go and deliver in one dose. However, the medication is liquid. I cannot just take this and go deliver it. I need to draw it up into the syringe, some amount of liquid. And what is available to me is 0.05 milligram of this medication per milliliter. Now I'm gonna go ahead and convert these micrograms to milligrams so I can compare it to my concentration. And again, if you remember how to do it in your head, converting micrograms to milligrams, great, do it that way. If you don't remember, always set it up the way we do it with DKP method. 60 microgram that I have to give. I don't know how many milligram that is. But I know that 1,000 microgram is 1 milligram. I always check to make sure I have my microgram and the microgram, milligram and the milligram. I find my diagonal to multiply and then divide by the leftover number. And I get 60 times 1 divided by 1,000. And that equals to 0.06 milligram. That is the dose in milligrams that I need to give, right? This is the dose in micrograms, and this is the dose in milligrams. Now I can go ahead and figure out my milliliters. .05 milligram is 1 milliliter, that's given. Now 0.06 milligram, I don't know how many milliliters that is. .06 milligram is X milliliters. And I get 0.06 times 1 divided by 0.05. And your X equals 1.2 milliliters. This is your answer. So let's review real quick. How did we solve this problem? First, we converted pounds to kilograms. We found that our patient weighs 15 kilograms. Then we found if 8 microgram is per kilogram of body weight, then what is appropriate amount for our 15 kilogram child? And we found that it's 120 microgram. We then said that it's per day. We need to find per dose. There should be 2 doses in a day divided equally, right? The amount we found, we need to divide equally into 2 doses. And we found that every 12 hours we'll give 60 microgram. Then we converted our 60 microgram to milligram in order to compare to our concentration and calculate our milliliters. You will find more dosage calculation for practice in my book, Dosage Calculations, Getting It Right Every Time.